Solve by completing the square, show all of your work. When I glance at this, first thing I'm noticing is that I have a common factor of 2 on the left-hand side. On the right-hand side, there's just a 0 there, but I can divide that by 2 also. So I'm going to divide both sides of this equation by 2. By 2, divide by 2. And when I do that, when I take out that common factor of 2 in my numerator and then divide by that 2, the left-hand side is going to become x squared plus 2x minus 5. And on the other side, 0 divided by 2 is still 0. So now I'm going to solve this using the method called completing the square. So I've got x squared plus 2x plus something to make a perfect square trinomial. Well, this 5 I don't want here, so I'm going to add 5 to both sides to kind of clear out the way so that I can complete the square on the left-hand side. So when I do that, now it's x squared plus 2x plus something that will complete the square. And over here, that's going to equal 5. Well, to complete the square on the left-hand side, again, I'm just taking half of b and squaring that because a, the coefficient, is happily just the number 1. So this is working very nicely. Half of 2 is 1. 1 squared is 1. So I'm just going to add 1 to both sides. When I do that, hey, I now have a perfect square trinomial on the left-hand side. This can factor as x plus 1 quantity squared. Again, it's the square root of this, the square root of this, the square root of x squared is x, the square root of 1 is 1, and the sign that goes between them is going to be this right here. It'll be positive. So, oops. So that's the left-hand side. The right-hand side is the number 6. Hey, look, I have a perfect square equaling a number. I can take the square root of both sides. This becomes x plus 1. Over here it equals plus or minus root 6. And then to solve, I'm just going to subtract 1 from both sides. So x equals negative 1 plus or minus the square root of 6. There we go. Number 15. Number 15, it says solve using any method, show all work. Oh, I can do anything? I don't like fractions. Many of you know that about me. So I'm going to eliminate the fractions by multiplying both sides here by 2. And also, just to make, while I'm at it, just to make this leading coefficient more pleasant, I'm going to multiply both sides by negative 2. So multiply both sides by negative 2. When I do that, right, negative 2 times this term becomes a positive x squared. Negative 2 times positive 4x becomes minus 8x. Negative 2 times negative 15 halves becomes positive 15. I like the look of that a lot. It looks a lot better already. Let's see. I was just doing completing the square, so I think I'll do that on this. I'm going to write this as x squared minus 8x plus something to complete the square. And of course, I'm subtracting 15 from both sides, right, to make that space. I'm going to be adding the same value here that I do to complete the square. For this problem, to complete the square, I'm taking half of this, so half of negative 8 is negative 4. Negative 4 squared is 16. And right here, I'm going to add 16 also. So this equation now, the left-hand side is a perfect square trinomial. I can write that as x minus 4 quantity squared. And over on the other side, negative 15 and 16 is positive 1. I take the square root of both sides. X minus 4 equals plus or minus the square root of 1. Square root of 1 is such a nice number. It's just 1. So my answer is x minus 4 equals plus or minus 1. If I'm solving this for x, I guess that means x equals 4 plus or minus 1. So there's two answers there, right? When I add, I get that x is equal to 5. And when I subtract the 1, I get that x is equal to 4 minus 1 is 3. There's my two solutions. Last question we're going to do I don't think I'm going to do that. Is number 16. Find the absolute value of, and then there's a complex number there. Find the absolute value of this complex number. Well, I've added a little Cartesian coordinate grid here, complex plane, if you will, because just like the real numbers, right, the definition of the absolute value of a real number is how far that real number is away from zero, right, the origin of the number line. And for complex numbers, the definition of the absolute value of a complex number is how far that is from the origin. Well, if I plot this, right, I've got my real number part, which is over 7, and then I'm going to go down 9 units. So this is a very crude sketch, but let's say that this right here represents go down 7 and then go down 9. Now, that's a point, right? This point would be -7 minus 9i, right? Because this is the real number axis, and here's the complex, the y is the complex numbers. So that point represents this complex number. The absolute value is just how far that number is from the origin, that distance. And, the formula that's there essentially is just an application of the Pythagorean theorem, right? This is 7. I went 7 units this way. I went 9 down this way. So this value right here is this. This is the absolute value of it. The absolute value, I'll just call it x, right? The absolute value is 9 squared plus 7 squared, or I'll write it like this. It is the absolute value of this is x is the square root of 7 squared plus 9 squared. So 7 squared is the 49, and 9 squared is the 81. And when I combine those two, notice there's no i's here at all, right? When I combine those two, I get the number 130. So the absolute value is the square root of 130. And just for reference, right, if I have a plus bi, that's some complex number, and I want its absolute value, that's very simply the square root of a squared plus b squared. And I hope you see the reason why, right? What we're doing here is we're just finding how far this is from the origin. That's it.